Check this out. It's operating solely on a CPU. You can see it displays LLAMACLI, utilizing only the CPU without involving the GPU. Hello everyone, it's great to see you. I'm Aero. I mentioned before that Microsoft has developed an LLM that uses only 1.5 bits per parameter, which means it can run with incredibly low memory usage. Well, they've released it now, and I've installed and tried it myself. What's remarkable is its low memory usage. It doesn't require a GPU. It runs smoothly on just the CPU. It really feels like the era of on-device AI is here. When Microsoft first mentioned 1-bit LLMs and the term BitNet, many were skeptical, but they started discussing 1-bit transformers under the BitNet name on October 17, 2023. They've since talked about the 1.5-bit model. I made a video on it. They kept publishing papers, and eventually they released BitNet with 20 billion parameters. You can install it right now too. I'll show you some demos. Previously, there was much discussion about using floating point 16 or 8-bit for inference. Now, the average is about 1.5-bit, with a maximum of 2-bit per token. The key is that even with just 2-bit, they've made an LLM that performs well. This means you don't need a smartphone with lots of memory. You can run it using CPU resources. One of the reasons on-device AI has been delayed is because it requires a lot of computing resources, making it hard for existing devices like smartphones to handle the performance demands. Let's explore the features of this large language model, and whether it will be limited to this or expand further, if on-device artificial intelligence will be quickly implemented, and if Microsoft will lead the way. My voice isn't great today, listening might be a bit hard, but this news is important. Let's go over it. So, they released a technical report this time. It contains a lot of detailed information, and this is the main point. They evaluated models with parameters ranging from 500 million to 3 billion. While discussions often focus on leading models with hundreds of billions or even trillions of parameters, such as the recent Gemini model with 1 trillion, it's crucial to acknowledge that these smaller models can still make a significant difference in specific areas. These smaller models must run smoothly on edge devices. This will unlock the potential of on-device AI. From this perspective, although these models don't yet match the performance of frontier models, they use significantly less memory compared to existing models like GPT 2.5 or 1 billion parameters, or even LLM 3.2 billion. This model is smaller. It has 500 million parameters. Its performance surpasses current models with 1 billion parameters, and while it's just under 3 billion, it still delivers outstanding results. The specific metrics are quite impressive. Models like Llama 3.2 billion, 1 billion, and 2 billion all generally require memory ranging from 2 gigabytes to 4.8 gigabytes. So smartphones have been rapidly increasing their memory from 2 gigabytes to 4 gigabytes. Even Apple, which typically takes a cautious approach to memory enhancements, is upgrading its devices to support on-device AI, incorporating features like Apple Intelligence alongside models such as ChatGPT. However, these smaller models still generally require a lot of memory. On the other hand, Microsoft's new 1.5-bit model with 2 billion parameters only needs 400 megabytes. With just 400 megabytes, there's no need for extra memory, right? This means that even current devices like smartphones, VR headsets, and laptops can run LLMs without requiring a lot of memory. This feature is truly remarkable. When it was first announced, many thought it was unbelievable, with comments like, wow, Microsoft's really stretching the truth now. But they actually went ahead and released it. Additionally, the training involved trillions of tokens, which is less than what a Llama used, meaning it wasn't trained on a massive scale. It uses less memory, so it needs much less energy. Compared to a Llama 3.0, it uses about 1/10 of the energy. From an engineer's perspective, the energy, performance, and memory usage are so optimized that it is truly impressive. On a CPU, its latency is incredibly fast. It's the fastest. Overall, it performs well across most benchmarks, and although it may fall short in some areas, it remains quite commendable. It excels in GSM 4K benchmarks. Its performance is strong compared to others. QNA 5.0 is well optimized. It uses INT4 models based on SABIT. In this instance, it's 700 megabytes, which is impressive. However, it performs better using only 400 megabytes. I tested it on an M2 MacBook Air, and there are also assessments using the Apple M2 Ultra. So, what insights does this provide us? BitNet compares to Llama using tokens per second on the vertical axis. This shows ChatGPT's expected performance. At this level, smaller models boost performance speed. They can generate several hundred tokens. This means they can create multiple pages in just 1 second. This shows how fast it works. You can see models like 1.5-bit large models. There are also models with 3 billion parameters. According to the analysis, ARM CPUs can experience speed increases of up to 5 times, while energy usage can be reduced by 50 to 70%. For x86 CPUs, speed enhancements can reach up to 6 times. Overall, its performance remains consistent consistently robust. More detailed information is available on GitHub. You'll need Python 3.9 or later. Install it, clone the repository, install the necessary packages, and compile the code to run it with Python. I've conducted some tests myself. It has some difficulties with Korean, but you can observe that the CPU is heavily utilized. For example, I'm going to type this sentence. One of the most effective strategies Donald Trump often employs in negotiations. As you can see, this operation is executed on the CPU, with Llama CLAI clearly visible here, functioning entirely on the CPU without utilizing the GPU, and the task is already complete. Let's move forward. Then it continues with 3, 4, and up to 5. You might have noticed Llama CLAI flashing briefly. It doesn't keep talking indefinitely, possibly due to token limits. For instance, make sure to answer all the questions until you have completed the entire text. If you examine this phrase carefully, you'll see it comes out quite well. For example, win-win mindset. While not always explicitly stated, how does Trump usually express it? When tested in Korean, it seems to handle both needs in a mutually beneficial way. However, there are some errors, indicating it's not yet fully optimized. What does the future hold for AI development? So, let's type in, what's the most crucial thing for a tech YouTuber to remember? What stands out as the key factor? For tech YouTubers, keeping up with trends is essential, along with a passion for technology. I am particularly strong in these two areas. Meanwhile, consistent creation and engagement with the community. If you watch my deep sea video, you'll understand what consistent creation means. I answer quite well. When the paper was first released, it claimed to work with 1.5 bit. Many thought it was a lie because even using int4 isn't effective. In fact, some said it would completely fail if used. But now, when you hear about training with just 1 or 2 bits, it seems puzzling. The term native is used for a reason. The term scaling native 1-bit LLMs is employed to emphasize that these models have been intentionally designed and thoroughly trained from the very beginning to function optimally using just a singular bit in their operations. When discussing 1-bit LLMs, there are typically two strategies. First, training a large model and then compressing it to 1 bit, or alternatively, designing and training it as a 1-bit model from the outset. The latter method posed challenges because the initial training needed to be effective for 1-bit functionality, which wasn't always achieved. However, this time, they managed it right from the start. Discussing 1-bit might seem complex, but typically, in AI computations within large language models, words are transformed into numerical values. These numbers undergo operations like multiplication and addition. These are commonly known as vector or matrix operations. For instance, with 8-bit numbers, you can represent values ranging from 0 to 255. For 16-bit, the range is 0 to 65,535. Similarly, with 1-bit, you can only represent 0 and 1. So when you multiply, the result either vanishes or stays the same. This is too extreme. How do we manage it here? Instead of binary, we use 3 values, 1, 0, and -1, which is why it's called ternary. Calculating log base 2 of log 3 gives us approximately 1.5. Sure, they use this as an average, but it's crucial to understand that during training, they actually apply 16-bit weights in the intermediate phases. In forward calculation, it stays as is. We call this backpropagation. During the period when we update the weights by bridging the error gap, we only use 0, 1, and -1, so the error difference isn't really visible. So they use 16-bit weights to better reflect the error, and then decide between 0, 1, and -1 again. What does that mean? While NVIDIA GPUs are commonly used for training, this AI model can efficiently run on a device using just a CPU without needing such high-powered AI capabilities. What I'm demonstrating now is operating on a CPU. Could you elaborate on the differences that exist between a CPU and a GPU? This is all running on a CPU, so the GPU isn't being used at all. If we can reduce a large language model to this scale for inference, it means on-device AI can be fully implemented. This is becoming more achievable with advancements like Gemma 2 and Gemma 3, although they still demand considerable memory. However, this model is much more compact and significantly reduces energy consumption, resulting in lower battery usage. When I share deep tech-related technologies, I always have a cautious mindset. I am very wary of the idea that this can never become a reality, because among South Koreans, I'm someone who follows tech trends very quickly. And since my job is to accurately understand and communicate this information to you, I take pride in my ability to grasp these trends effectively. In the past, I've come across remarks like, quantum computers will never work, or will AGI ever become a reality? I remember those comments clearly. A year later, we see more potential and some implementations. Comments about autonomous driving being impossible are now rare. It's quite amusing. Back then, many were convinced that autonomous driving was impossible, no matter what I said. However, the world evolves rapidly, and even experts are not immune to these changes. Even industry experts often argue that certain AI models can't work without NVIDIA GPUs and floating point calculations. They critique using 4-bit precision to boost performance. I understand their view, but experts can sometimes be too confident in current methods. Then, innovation happens. That's the essence of innovation. Microsoft is not claiming to outdo frontier models right now. These smaller models can be very useful in many cases. As applications utilizing this AI are developed for on-device use, these models will be in high demand. AI models using 1.5-bit precision precision aren't just feasible. They can greatly cut down on energy consumption and memory usage, operating solely on CPUs. This highlights the swift pace of change in the world. If Microsoft launches this, will Google or Meta just watch? They will all try to catch up. It's true it might not be possible right now, but that's how the world evolves. I'm saying that predicting the future too early can lead to missed opportunities. For example, many of our followers are into stock investments. If we judge too quickly, we might become too skeptical or make errors. Thinking advancements won't happen soon, and only focusing on Excel functions may not help. Not learning programming through live coding could also be a mistake. These things might not help you and could even reduce your competitiveness. I'm not saying you're doing anything wrong. I share this perspective out of concern. Please share your thoughts. I'll keep bringing you updates like this. Uni's hoodie from the Andal Engineering Store is very popular right now. It's high quality and looks great. Perfect for coding sessions. Group orders are welcome. If interested, please reach out. This has been Error.